Alright, chapter 12, branch circuit feeders. I'm live. Alright. Objectives: identify the feeder and branch circuit portion of the distribution system. Describe the various types of branch circuits. Define the functions of a feeder and the functions of a branch circuit conductors. Okay, go here real quick. Here's our lateral. It's coming into where our main service disconnect is, so this is where the meter and everything would be. Our feeders going across to the distribution center, and then our sub feeders going to the individual panels. Panel boards are in the code book, they call them panel boards, not panels. And then we have our conduits that go off to the branch circuits. Calculate lighting receptacle loads using the code requirements. Save branch circuits in accordance with the code. Determine the branch circuit overcurrent protection required by the code. This is our breaker for our branch circuits. And use a code to size the feeder conductor. So when we go to that feeder, to sub feeder, or the we have to size it to be able to handle the load that's being plugged in. Definitions. Before I get there, it says an electrical system power system must be transferred from the service equipment to the lights, machines, and outlets regardless of the wiring method used. The conductors carrying the power fall into two categories, either a feeder or a branch circuit. This chapter will explore characteristics of both types of conductors. Definitions. Service conductor. These conductors extend from the power company terminals and the main service disconnect. So power from the power, so it comes off either a lateral, would be underground, a overhead, that's when it comes overhead. A feeder, the conductor that originates at the main distribution or main disconnect device and terminates at another distribution center, panel board, or load center. So I'll go back to the picture and I'll show you. Sub feeders, these conductors originate at the distribution center and other than the main distribution center and extends to the panel boards, load center, and disconnect switch that supply branch circuits. Panel boards. This can be a single panel, multi-panel, containing switches, fuses, and circuit breakers for switching control and protecting circuits. And on this one, it can be a single or a double. Guess what? I can have a feeder coming across that feeds one panel, and then from there goes up and feeds another panel. They usually do that a lot. They do that a lot, and they may have a 100 amp. Let's say on the first floor they got a 100 amp panel, and on the second floor they have a 100 amp panel, and they feed it with 200 amp wire. So you got 100 amps per panel. So instead of running two conduits, you run one conduit and feed them both, and it's perfectly fine. Branch circuits. It says transfer power to the load device. The portion of the wired branch the system extending past the final overcurrent device. These circuits originate at the panel and transfer power to the loads. So the branch circuits, when we talked about on the overcurrent device, and I said, well, where does the power come from? Well, it comes from the point of supply. Point of supply goes to the branch circuits, your outlets, your lighting, your dishwasher, your disposal, your dryer. All of that comes out of the panel boards. So here is our service that's usually done by the utility, whether it's underground or overhead. This is where the meter and your main disconnect. A lot of times this may be outside, more in commercial than it is in residential. It'll be outside where you have maybe a 400 amp, 600 amp fuse or breaker outside feeding, and then it goes to a distribution center. So from here is just the main disconnect. So you got to turn power off the whole building. This is where you go. You don't have to worry about going here and going here and going there. This may be outside. This may be inside a main distribution, and all your panels that are within that building would come out of your distribution center. So this is my service conductors, whether it's overhead or underground. Here are my feeders coming between the main service disconnect and the distribution. So here I may have, let's say, a 400 amp panel. I got a 400 amp breaker here or fuse. and then it comes across and it comes to here, and then here I have a breaker, 200 amp breaker for this one, I have a 200 amp breaker for this one. Because there is no transformers or anything, this is being supplied by one type of voltage. Let's say it's a commercial with a one phase, with a three phase. So this might be a 120/208 three phase, because both panels come out of the same distribution, so they're both going to be the same voltage. They're both going to be the same voltage. At the school we got a little bit different. Across the street at the main campus, that's where the main service disconnect is. And then they have a line that comes up to the school, and it goes to that gray box behind us. So it comes up, and then there's a transformer there, and then from there it goes in. It goes to the inside our classroom, and it feeds that panel HA. I think it's HA, high A. And then from there it goes out. So we have a subfeeder. We have a feeder that goes to panel HA, and then from that HA it goes out to the transformer, and from the transformer it comes back into panel LA. And I'm talking about the two panels in the front of the classroom, and that's how that's fed. And then all our lighting, all our motors, come out of the HA. Our power, our receptacles, all come out of LA, which is low voltage. The other one is H4, high voltage. Okay, but because we have different voltages, that distribution that sits outside, it goes out, and there's a feed that goes to the panel in the greenhouse, and there's another one that comes out and it goes to the panel in our yard area, our shop area. I forgot my clicker, so I got to do it manually. Branch circuits. So it says any circuit that extends beyond the final overcurrent protection device is called a branch circuit. This includes circuits servicing single motors, individual circuits serving many lights, receptacles, multi. Branch circuits are usually low current, 30 amps or less, but also can supply higher currents. What would be a higher current? Let's say you got a range. Your range is an electric range, is 50 amps. Or you have cooktop and a single oven, or a cooktop and a double oven that's electric. So it might be 50 to 60 amps, depending on which one it is. You got your water heaters, they're electric. They're usually around 30 amps. Your air condition, they can run anywhere between 25 up to 50 amps. So depending on the size, it's your load. So it's still a branch circuit. It's still a branch circuit. When you have motors, when it's feeding the motor, a single motor is called individual. But when you have one wire or one run feeding multiple motors, now that's a feeder. Okay, we'll get into that in the next chapter. And it says the branch circuit is made up of conductors extending from the final overcurrent protection device to the load. Some branch circuits originate at safety switches, disconnects, but most originate at a panel board. Okay, so we have individual, multi-outlet, general purpose, and appliance, and multi-wire. So this is an individual branch circuit. A branch circuit supplies a single load. So, and then let me go here, and then sizes for load it will supply. So that would be this one here, the loaded supplies. That is a branch circuit rating. A branch circuit size for the load it will supply. Sizing the circuit for the additional future loads is a good practice. The rating of the branch circuit depends on the rating of the overcurrent device protecting the circuit. Branch circuit service only one device can have many ratings, while a circuit supplying more than one load is limited to 15, 20, 30, 40, and 50. So always remember, when we talk about branch circuits, we're talking about the range, the dryer, the receptacles in an office, the receptacles in like in our house, okay, the kitchen, the washroom, the garage. Those are all branch circuits. Whereas when you get in a commercial area, they're all branch circuits. When it starts changing, that's when you start talking about feeding motors. You got a circuit feeding something big. It's completely different. So when you start talking about a piece of motor that's 100 amps, that would be a feeder. Okay, so if you got a 100 amp motor, that is a feeder, because now you're getting up there in sizes. Again, smaller motors, it's a branch circuit. Bigger motors like that, they would call a feeder. And then this would be 1222. This is branch circuit voltage. Oh, it depends on, I'm sorry, still at 1221. So it says depends on the rating of the overcurrent device. So when we're putting in our overcurrent device, it depends. It's on the wire. What is the load? What is the wire? So if I got a 12 gauge wire, I got a 20 amp breaker, maybe a 15 amp breaker. Okay, or I got a 14 gauge wire, I got a 15 amp breaker. So depending on the wire, it's what dictates what our load is. But when we're doing receptacles, those are either 15 or 20. Can't be anything more than that. When we're doing lighting, 15 or 20. If we got a feeder that's feeding the panel, that's feeding the bank, that's completely different, because we're coming off a breaker to feed a bank of fluorescents off of a sub panel. Okay, so it's a little, or off of a feeder, off of, I've done it many times when we come in and we have a 50 amp 3-pole breaker feeding fluorescents in the room, and then it goes down to a time clock turns the power on and off. But then it's got a little sub panel there, but it's considered a feeder. Okay. On these classifications, I just wanted to go here. So an individual branch circuit. So this would be your individual, one hot, one load, and your neutral coming back. A general purpose. What is a general purpose? Okay, general purpose is all your receptacles in an office. In a house, where's your general purpose? Your general purposes are in the bedroom and living rooms, hallways. Okay, once you get into the dining room, kitchen, and washroom, well, the dining room are considered part of the kitchen, so those are appliance circuits. Okay, remember, when we do load study, when we're doing the feeder sizing, we have to add 2 loads for the kitchen. We have to add 1 for the laundry room. Always remember that. General purpose is everything else. In a, let's say we're doing a Rouse, and your cash registers, those won't be a general purpose circuit. Those would be more like an individual circuit. You got 1 load. A lot of times they'll put like 2 cash registers on 1 circuit. Why? They don't want to make sure that the breaker doesn't trip. Okay, they want to make sure that the breaker doesn't trip to turn the cash register off. So general receptacles is because these people go in there and plug whatever they want to, or somebody's out there to do something bad, and then they get a piece of aluminum foil and use a pencil to get it in. Anybody do that in high school? I didn't either. But they don't want, if you turn power off. So a lot of times also the other thing is never mix lighting with receptacles in commercial. Try to keep them separated. Reason is, if this receptacle, if somebody plugs something in there and it trips and it controls the lights in that room, what happens to the lighting? The lights go out. If you don't have an emergency, that's not going to have an emergency system. The emergency system would be on the building. If the building went down, then yes, your emergency system comes on. So you want to make sure that when you're putting in lighting in an area, that keep your receptacles and your lights separated, so in case one fails, it doesn't affect the other. But this is general purpose. That would be your general lighting. Your lighting is general. Okay, it's a circuit that controls the lighting for general area. If now they get specified, sign light outside, the walkway lights outside, the parking lot security lights, now those are specified as something different. But general is inside the store. All the lights come on. And then this one over here, individual multi-wire branch circuit. Individual multi-wire, it's this drawing right here. So I got 2 hots coming down. So one of them is switch going to one receptacle, the other one is hot going to the other. I have my neutral coming down, and then here's my ground. Okay, this would be here, and if you notice, it's got a bar across right here, just as I got mine. I just made mine solid. So that means this would have to be a 2-pole breaker. Okay, if I had here, this is a multi-wire, same thing, but I got 1 hot going to 1 outlet and another hot going to the other outlet. If it was a three-phase, I would have my third one, but because I only have the black, red, blue, and the green, so I can't add one because I'm using the yellow, the blue as my neutral here. But I can add a third of it was a three-phase, black, red, blue, and then my neutral. Okay. Then here, this would have to be a two-pole breaker. Why? Because it's got a hot on the same receptacle. You don't want to go in there and turn one off, and then all of a sudden, oh, okay, power's off, and you reach in there and this one's still hot. That's why it's on a two-pole breaker. Here, this box may be on one receptacle. I mean, this receptacle may be in one box, this receptacle's in another box. Or they're in the same box, but they're separated. They're two separate receptacles, and then that's why you don't have to have a two-pole breaker here. Okay, here these are single 15 amps, not duplexes. So my breaker would have to be a 15 amp. That's why I got a 15 amp breaker if it's a single receptacle. If it was a 20 amp, if I need a 20 amp circuit, and then I have to use a 20 amp receptacle. Okay, just remember, I'm going to use a water analogy. So here, I can put a 20 amp, well here they would have to be 15s because half is getting one, half is getting the other. But let's just say it's a regular duplex with one hot going to it. I could put a 20 amp circuit, I could put a 20 amp breaker on a duplex. Why? Because I got two hoses that are plugged in, and I can get 15 amps out of here, and I can get 15 amps out of here. Okay? If I do that, what's going to happen to the breaker? If I got a 20 amp breaker on a 20 amp, 12 gauge wire, 20 amp breaker, what's going to happen to the breaker? Breaker's going to trip. Big deal. Okay? But I can get 15 here and I can get 15 here, looking at a duplex with one hot in it on a 20 amp. That's why you can do a duplex on. On a single receptacle, it has to be rated. So this is a 15 amp. My breaker has to be 15 amps. I can have 12 gauge wire, but my breaker can't be more than 15 amps. Why? Because I only got one hose that can plug in to give me water. And when I get that water, well, I can only get up to 15 amps because that's what the receptacle has. So if I needed to use a 20 amp single receptacle, if I needed a 20 amp breaker, 12 gauge wire, and then I have to use a 20 amp receptacle. And then the other one was the multi-outlet strip. It's that gray strip that I have with the multi-outlets. Yeah, so that's a multi-outlet. This is a plug strip, but multi-outlet strip. Say you have the wire mode that I have where the computers are at. That's a multi-outlet. Why? Because it's a handmade one, but it has multiple outlets in it. And you have multiple circuits going to it, but it's still a multi-outlet device. Alright, voltage limitations. Voltage limitations. It says brand circuit voltage limits are contained in section 210.6 of the code. These limits are based on the equipment being supplied by the circuit. In the residence and hotel rooms, circuit supplying light fixtures and small receptacle loads cannot exceed 120 volts. So again, a hotel is just like a house. A hotel motel is just like a house. Okay, 120 for all your circuits. Your lighting has to be 120 volts. Okay, now the higher the voltage, like in the classroom, look how high the classroom is. Okay, so they can have that 277. It's fluorescence, but for most parts, in a hotel, they treat it like a house, so it's 120 volts for your lighting and your receptacles. When I was doing the hotel, we ran up and we took what was number one? I think it was number ones, and we fed 7 panels. I'm sorry, because it was 7 floors above. It was 8 floors, ground floor, and then 7 floors above. So we had a panel in each room, and the panel went straight up, and we just caught the panels as we went up. So we fed 6 panels with one feed. 6 panels with one feed. You know, I was talking about the little wedges we use and everything when we're talking about our conduit runs. Circuits 120 volts or less. Circuits that are 120 volts or less may be used to supply lamp holders, auxiliary equipment, electric discharge lighting, receptacles, and permanently wired equipment. So again, still using 120 volts, you can have them anywhere. It's just your general voltage. And in branch circuits exceeding 120 volts but not exceeding 277 volts may supply mogul base, screw shell lamp holders, ballast or fluorescence, ballast and electrical discharge lighting, plug connected appliances, and hardwired appliances. Incandescent lighting operating over 150 volts is permitted in commercial wiring, and a school is considered a commercial wiring, so that's where we have 277 lighting. And then circuits exceeding, circuits between 277 and 600 volts. It says circuits exceeding 277 up to 600 volts can supply mercury vapor fluorescent lighting, provided that the lighting units are installed at heights not less than 22 feet above grade and in tunnels heights not less than 18 feet. So it's like you go to Home Depot, a lot of times those big stores like that, their lighting may be 480. Why? Because they can put more lights on one circuit. You take one, now they have 277, it may have, let's say, an amp and a half. Well, they kick it up to 480, now it's to 3/4 of an amp. Now look at how many lights they can put on one circuit. So now they can run one or two circuits, so they're only using 2 circuits to light up the whole store. Power-wise, their bill is still the same. It doesn't matter. If you're at 480, let's say hey, you have something at 480 volts, and it's 1 amp. And you get that and you knock it down to 120 volts. Same thing. At 120 volts, now your amps are going to be 4. Power 4 times my watts. Okay, if I got 1 amp, 480 volts, what's my watts? My watts is 480. Well, how do I get from 120 to 480? Okay, I divide that, so that's 4 amps. So it doesn't change. Power-wise, it's still the same. It doesn't change. Your electric bill, it doesn't save you. But your capacities, your infrastructure, what you use, your wire, your conduits, you're using less at a higher voltage because you can put more things on the circuit that you can. Because if I have a light, let's say if I have a 450 volt, a 450 watt light bulb, and I power it at 480 volts, okay, I got less than an amp, but I still get that same 450 watt light bulb at 120. Now that thing's going to have almost 4 amps. Okay, so that's the difference. So here I got a 15 amp breaker. I can only put 3 lights. Or a 20 amp circuit, I can put 4 lights. If I got 4 amps per circuit, okay, I can't put more than 4 on the circuit. Okay, 4 amps, 4 amps, 4 amps. That's 16, almost 16. Okay, so 16 times 80 because it's on more than 3 hours. It's lighting, so it's a continuous duty. So I can't have more than 16 amps. Okay, now turn around and do that at 480. And I got 1 amp. Now I can have 16 lights on one circuit, maybe 17 lights on one circuit. Okay, so that's less wire that I got to run, less breakers that I have to use. Alright, branch circuits. This is a conductor ampacity and multi branch circuits, 1223 and 1224. That's what's on this slide here. So it says the amp rating of a branch circuit conductors must be greater than the maximum load the current will provide. What does that mean? That means is I got to size my circuit. I got to size my circuit to carry the load. Okay, so my circuit's got to be greater than the load I'm plugging in. For multiple loads, branch circuits, the conductor's ampacity must correspond to the rating of the overcurrent protection device. So again, whatever wire I got, if I'm plugging in a lot of things plugging in, okay, so say I got 3 motors, I got 3 things I got to plug in, and each one is 5 amps. Okay, each one is 5 amps. I got a 20 amp breaker. Okay, 12 gauge wire. I'm fine because I can carry it. I'm not exceeding that 16 in case it stays on for an extended period. So I'm allowing myself. So that's what you have to look at. You're sizing the circuit according to what's being plugged in. Multi-branch circuits, grounded conductor, 2 conductors. So this is where I had here. So here's my multi-conductor. So I got 2 hots, 1 neutral, 2 hots, 1 neutral. This would be like on a single phase. If I have a 3 phase, I can put 3 hots with 1 neutral. Forgot on that part. It says the conductor is acceptable. It says the DDD. However, for circuit supply and hardwired devices such as electric heaters, air conditioning units, and water heaters, the fuse of circuit breakers can be rated at the next rating. What does that mean? You know, I got a motor that's using 15 amps. All I need is a 14 gauge wire. Okay, but my overcurrent protection device, my breaker with my short circuit protection, is not an overcurrent protection, it's short circuit protection. So my breaker for that motor is going to be 250% more than that motor. Okay, so I would have a 14 gauge wire. I got 15 amps multiplied by 125%. That gives me just shy under 20, a little bit over more than 19. And then, so a 14 gauge wire can handle 20 amps. Okay, the THHN. But my breaker is going to be twice that. Okay, my breaker is going to be a 40 amp breaker. Okay, so I can have, as long as the wire can carry the loads that's being plugged in. Same thing with a water heater. Okay, I may have, the water heater may say 22 amps. Well, I can't put a 25 on it, so I got to put a 30, so it's the next size up. But the wire's got to be able to handle the load that's being plugged in. Okay, so the wire has to be handle the load that's being plugged in. So the ampacity of the equipment, the wire has to match the ampacity of the equipment. The breaker may be a step up. Conduction sector. There was one more thing that I read here. Oh, here it is. It says the smallest general purpose conductor for branch circuits is a 14 gauge. Okay, so our smallest building wire that we use is 14 gauge. Then it goes on, it says tap conductors must be smaller. See section 210.12 for more information. Okay, so what are they talking about a tap conductor? In a tap conductor, they're talking about, let's say I got a J-box. So here's my conduit coming in, and here's my conduit going out to another J-box. And I have a flex. This is a fluorescent, this is a light, fluorescent light. These are the lay-in light. So I got a J-box, and this is my flex going over to this fluorescent, and that one's going to there, that one's going to there, that one's going to there. Okay, so what we used to do is we run a 12 gauge, and then we take a 18 gauge out of the box. We take an 18 gauge over to the fluorescent. Inside the fluorescent, we'll put a 1 amp fuse. So that 1 amp fuse is protecting that 18 gauge wire, because that wire only has to carry the load of that one light. There's no other lights being plugged into it. Okay, the wire going that way and the wire going that way is carrying the whole load of all the other lights together. But the wire going from here to here, here to here, here to here, and here to here, only has to carry the load of each light. Because I got my black and white going here, a black and white going here, a black and white going here, a black and white going here. And on that black wire, I got a fuse on it. So in case there's a problem, that fuse trips, and then now the wire has no load. So that fuse is protecting that wire. That's a tap conductor. When we're sizing loads, earlier I read, and I forgot to mention that, it was talking about always leave. It says sizing a circuit for additional future loads is good practice. That was on 12.2.1. So here's an example. So for most parts, let me erase this part down here.